Happy Thursday, 7th graders. I hope you guys are doing well. I'm excited to see you guys tomorrow and go over and see how you guys are doing on Pythagorean theorem problems. Today is going to be our third day of this. The first day we learned on what the formula is. Second day we did some practice problems. Today our learning target is going to be I can use the Pythagorean theorem to solve application problems. So we're going to look at some real world examples of where you would need to know the formula on how to apply it to solve the problem. Please go ahead and pause this video and write the learning target in the top right hand corner, and then we will get started with a real life application problem. Alright, before we get started, if there are any questions, again, I will be back tomorrow and I would be more than happy to go over all of them with you. With that, our first example, Mr. Vang leans a 17-foot ladder against the tree. The bottom of the ladder is placed 8 feet from the base of the tree. How high up is the top of the ladder from the ground? So based on the problem, we have a 17-foot ladder. So that is going to be 17 feet. That goes right here. We can see it already labeled. Again, after 2 days, this diagonal piece that's leaning from the ground to the tree is going to be our hypotenuse, because the tree and the ground make a 90-degree angle, and it is diagonal from that. Second part, the bottom of the ladder is placed 8 feet from the base of the tree. So again, we know that from the base of the ladder to the base of the tree is 8 feet. And we are trying to find out how high up the ladder goes against the tree. So if we are doing the formula a squared plus b squared equals c squared, the first thing we have to do is we have to plug in what we know. So we said that 17 was our hypotenuse. Our hypotenuse is our longest side. It is always equal to c. So we are going to plug in 17 for c. And it kind of looks like this 8 feet is going to be the shortest side. Again, you can plug 8 in for a or b. I'm just going to plug it in for a, because I typically like to keep things consistent, and so I always have my shortest side be a squared. So then our next step is we're going to get rid of as many exponents as we can. So 8 squared is 8 times 8, that's 64. We can't get rid of the b squared yet. And 17 squared, or 17 times 17, is 289. So again, at this point now, again, there's 2 steps that we have to do to find out what side B is equal to. We have to get everything, all the numbers on the side with the variable to the other side. So we're going to take away 64. That leaves us with 225. And then to get b by itself, we have to get rid of the exponent, so we take the square root. The square root of 225 is 15. just to double check, 225, the square root is 15. So B is equal to 15 feet, which is how high the ladder is at the top from the ground. All right, next, example 2, we have an 18-foot flagpole that casts a 4-foot shadow from the base of the pole to the end of the shadow. What is the distance from the top of the flagpole to the end of the shadow? So we have an 18-foot tall flagpole, that is this side right here. It casts a 4-foot long shadow that goes right here. And we are trying to find the distance from the top of the flagpole to the bottom of the shadow. Let's try this actually. Alright, put a question mark in there. So again, if I locate my right angle, that's where the flagpole meets the ground. The side that is the opposite from that is our hypotenuse, or C, and that's what we're trying to find out. So if I have a squared plus b squared equals c squared, I'm going to put 4 in for a, so it's 4 squared plus 18 squared is equal to my missing side c squared. So 4 times 4 is 16. We have 18 squared next, which is 324. And we are still trying to find out what c squared is equal to. So if I add these, that is 340. And then the last thing would be to take the square root of that. So again, 4 squared plus 18 squared, double check, is 340. If we take the square root of that, c is approximately equal to 18 and a half feet. Now, you could write it as c is equal to the square root of 340 as well, but I'm going to write it like this. Alright, so here's what I want you to do. I want you to copy down this problem in your notebook, and then I want you to pause the video and try to solve it, and then check to see if you got the same answer when you're done. Alright, so a right triangle has one leg that measures 5 feet and a hypotenuse that measures 13 feet. What is the area of the right triangle? So, this question is asking you to do 2 different things. So let's start with the first one. The first thing we have to do is find the missing side. So we know one side is 5 and the hypotenuse is 13. So if we're looking at this and we're trying to figure out what the area of the triangle is, do we have enough information to find the area? We do not. Our area is 1/2 our length times our base, which are these two parts of the triangle, and we are missing this side. So it's 5 squared plus b squared is equal to 13 squared. So 5 squared is 25. Because the first thing we're going to do is get rid of our exponents. B squared has to be the same for now, because we don't know what b is. And 13 squared is 169. All right, hopefully through this part so far you are at the same point as we are right now. 25 plus b squared equals 169. If you're not, go ahead and pause it, change it to this, and see if you can come up with the correct answer. Now, we have to get b by itself to find out what it's equal to. So the first thing we're going to do is take away 25 on both sides. That's going to get b squared by itself. And that's going to be equal to 144. To get b by itself, we just take the square root. So b is equal to 12 feet. If you got something besides 12, why don't you go back and look at what you did and see if you can identify the part where your answer or path changed from mine. All right, example 4, and it has an S by it. So again, I'm going to have you pause the video, copy this down, and solve it on your own. The problem is the square sandwich is cut diagonally so that the length of the diagonal cut is 7 inches. How long is one side of each slice of bread? Oh boy. You know what? Just thinking about this, we never actually finished this problem, did we? So we got 12 feet for this side. But the question that we were supposed to solve is, what is the area of the triangle? Area is equal to base times height divided by 2. So the last thing you should have done is 5 times 12 divided by 2. 5 times 12 is 60, and half of 60 is 30. So our area is 30 feet squared. Whew. All right, for this one, if you haven't paused yet, go ahead and pause it and try it. All right, so we have this triangle right here. And what we are trying to figure out is this part right here. And we know that this diagonal line right here is 7. So the big question is going to be, how are we going to find out what the sides are that are the same length? So we know that typically what we have been doing is we have been doing a squared plus b squared equals c squared. But the big question is going to be, how does it change when our sides are the same? Because in this example, we only know that C is 7. We don't know what A or B is. We just know that they are the same size because it is a square. And we know that squares are the same size. So what we are going to do is we are actually going to say it's a squared plus a squared, since we know that they are the same length. And a squared plus a squared, by having them both be a, that is going to help us out. So what is a squared plus a squared? Sorry, I'm having a little trouble writing here. A squared plus a squared and we know that 7 squared is 49. So I'm just going to write that in right away so that I get rid of that squared part in our answer. A squared plus a squared is 2x, or 2a squared. And so what you would do then is you would divide 49 by 2 and then take the square root. And we get approximately 5. which makes sense because 5 squared is 25, and 25 plus 25 is close to 49. All right, that is our last example for today, so please go ahead and finish the notes and then take a peek at the assignment that goes with this. Thank you guys, and I'm looking forward to seeing you tomorrow.